Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem-solving skill in mathematics. First, we will analyze the problem on hand to find the related concepts. Then, using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in mathematics. In this video tutorial, we will discuss the differentiation of three polynomial functions from definition. The question is as follows. Differentiate the following functions from definition. 4. fx is equal to x square, 5. fx is equal to x cubed, and 6. fx is equal to root x. We have already discussed the related concepts in the previous video. Hence, we will directly go for the solution. In question 4, we have fx is equal to x square. Therefore, f of x plus delta x is equal to x plus delta x whole square. Therefore, in the first step, the derivative of this function is defined as f dash x is equal to limit delta x tends to 0 x plus delta x whole square minus x square divided by delta x. In the second step, we have simplified to get f dash x is equal to limit delta x tends to 0 2x delta x plus delta x whole square divided by delta x. In the third step, we take delta x common in the numerator and then cancel it with the delta x in the denominator. We can do this because delta x tends to 0 implies delta x not equal to 0. This gives f dash x is equal to limit delta x tends to 0 2x plus delta x. Since the delta x in the denominator is removed, now we can put delta x is equal to 0. Therefore, in the fourth step, we get the final result f dash x is equal to 2x. Therefore, we write d by dx of x square is equal to 2x, which is the answer to question 4. In question 5, we have fx is equal to x cubed. Therefore, f of x plus delta x is equal to x plus delta x whole cube. Therefore, in the first step, the derivative of this function is defined as f dash x is equal to limit delta x tends to 0 x plus delta x whole cube minus x cubed divided by delta x. In the second step, we have expanded x plus delta x whole cube in the numerator. In the third step, we have simplified the numerator and taken delta x common in the numerator, which gives f dash x is equal to limit delta x tends to 0 delta x into 3x square plus 3x delta x plus delta x whole square divided by delta x. In the fourth step, we cancel delta x from the numerator and denominator, since delta x tends to 0 implies delta x not equal to 0. And after the cancellation, we put delta x is equal to 0. Therefore, in the fourth step, we get the final result f dash x is equal to 3x square. Therefore, we write d by dx of x cubed is equal to 3x square, which is the answer to question 5. In question 6, we have fx is equal to root x. Therefore, f of x plus delta x is equal to root over x plus delta x. Therefore, in the first step, the derivative of this function is defined as f dash x is equal to limit delta x tends to 0 root over x plus delta x minus root x divided by delta x. In the second step, to rationalize the numerator, we multiply and divide by root over x plus delta x plus root x and simplify. Therefore, in the third step, we write f dash x is equal to limit delta x tends to 0 x plus delta x minus x divided by delta x into root over x plus delta x plus root x. We simplify and then cancel delta x from the numerator and the denominator as delta x is not equal to 0, which gives f dash x is equal to limit delta x tends to 0 1 by root over x plus delta x plus root x. Then we put delta x is equal to 0 to get f dash x is equal to 1 by root x plus root x. Therefore, in the fourth step, we get the final result f dash x is equal to 1 by 2 root x. Therefore, we write d by dx of root x is equal to 1 by 2 root x, which is the answer to question 6. This completes the answer to the question.